Silver has started, and you guys should start design. Otherwise, it will be very difficult, right? So in the previous class, we derived this, right? So this, we had this fluid liquid which was flowing, right? And we derived the Bernoulli's principle. And what was that? So this was right. This H1 and what is that? This was pressure P1. This was pressure P2. Was N2, and this was P2. Is that, and then we had derived that from Bernoulli's principle. What was the Bernoulli's principle? It stated that P1 plus half rho P1 square plus rho G. This was equal to P2 plus half rho P2 square plus rho G H2. Right. This was derived, and we stated that P plus half rho P square plus rho G H. This would be constant. So what was this P? What was this P? What was this term? How did this term arise? Yes, guys. So
Is
how
it
did we
pressure?
get? Yeah, this is pressure, but we got this from pressure energy, right? So this is pressure energy per unit volume, right? Pressure energy per unit volume. What was this per unit volume? And then this thing, what was this thing? This was potential energy per unit volume. So this relation states that the total energy is a constant, right, in the motion of so now now we will study about the application of application of these. So there are two applications, but the other part is omitted from syllabus. So one is Torricelli's law, right, which gives us the speed of efflux. and the other one is venturi. This part is not right. So we will talk about this thing. This is very important. Very important, and yeah, let us understand. So we have let's say you guys, all of you guys have those water tanks in your at your rooftop, right? So all of you guys have those water tanks,
Yes, sir.
and then you have a tap, not a tap, but a pipe beneath that tank, right? So at the bottom you have this pipe, right? You have this hole, and from that hole the water are flowing up, right? So let's say you have this tank, and this is closed. Right? So you have this big tank, and then you make a hole at this point, right? So then the water will come outside, right, right, guys.
Yes, sir.
So you
Yes,
have
sir.
made a hole at this spot, yeah, and this hole is very small, right? So this hole is very small. And before I do that, let me ask you this question. So what is the equation of continuity? What is the equation of continuity, guys?
Sorry, sir.
What is the equation of continuity? For the case of steady flow, what is the equation of continuity?
A1 is equal to A2 V2.
Yeah, absolutely right. Good. So A1 V1 is 8. Yeah. This is the equation of continuity, right? So it states that the mass flowing in and the mass flowing out, they are in the steady flow, right? So yeah, good. Okay, so we will use that idea in and this tank is full, right? This is this. And this is the surface of the tank, right? So inside this surface, we will have some pressure, let's say P1, right? And this has some area, right? So let's say the water is flowing down. So at this part, the water is flowing downward, right? So the volume is getting decreased. Water is flowing out of this part. So water level is going down at this part. So water level is going down with, let's say, V2, V1 speed, right? And let's say this height is H1. This height is, let's say, H2, right? And this is open. So what is the pressure here? This is open. So what is the pressure here? Yes, guys, what is the pressure? This is open. What would be the pressure?
B1, B1.
Pressure would be atmospheric pressure, right? This is open. So atmospheric pressure would be there, right? Right?
Yes, sir.
Okay. And then this has some velocity with which the waters are flowing up. So then let's say this is V2. So we have all these things, right? And let's say this separation is H. So let me write it in something. This is H. Okay. Now, if we apply, so what have I written? Sorry. So if I apply the Bernoulli's principle in this system, so what would be that? Applying the Bernoulli principle. What would be the Bernoulli's principle? V1 plus half, and this is water, right? So rho and V1 square plus rho G H1. This is equal to how much? V2 plus half rho V2 square plus rho GH2. Am I correct, guys?
Yes, sir.
Okay. So this one, and now let us write all the values. So this is P1 and half rho V1 square plus rho GH1. V2 we can write as PA plus half rho V2 square plus rho GH2. Right. Now let us write this as equation 1. Right. And now, can you guys tell me about the areas in these two parts? So this area is 8, right? So what we can write about the areas of this tank and then area of this hole. So this area of the tank would be area of the surface of the tank that would be very, very greater than. Is this correct, guys?
Yes,
Yes.
sir.
Okay. So now applying continuity equation. So from continuity equation, what we can write A1 B1. This is equal to A2, right? So V2 would be how much? V2 would be A1 by A2 and V1, right? Or if we write V1, right? V1 would be A2 by A1 and B2, right? Is this thing okay?
Yes, sir.
So now we see that A1 is very, very, very larger than A2. So A1 by A2, that would be very much larger than 1. So if I write the reciprocal of it, so A2 by A1 would be pretty smaller than 1, right? Is this thing correct?
Yes, sir.
Yes, sir.
So, I can write V1 as very, very, right, smaller than V2, right? So, in comparison of V1, I can write, in comparison of V2, I can write V1 as 0, right? Because let's say if you have V2, which is, let's say, 100 meter per second, and then you have V1 which is 0.003 meter per second. So in comparison to V2, V1 is how much? 0, right? That is very small, right?
Yes, sir.
Yes, sir.
And you guys have seen so you guys at some point you guys have seen the tanky, right? So when you look at the water tank, so the level of the water tank is going down with a very less speed, right? The water flowing at the bottom, that flow of water is pretty large, but the water level that is going down, that speed you cannot see, right? You cannot see that if the water level is going down. If you have a very small, right? But let's say okay, just destroy this part, and this hole is very large, then this level will go down faster. But if the small is, if the hole is pretty small, if this area is pretty small, then this V1 would be very small. That is what I'm trying to make, right? That is what I'm trying to say. So in comparison to V2, I can ignore this V1. So now my V1 is 0, right? So putting this value back in the, so this is, let's say, second. So putting V1 in equation. What was the equation one? V1 plus half rho V1 square. So that and plus rho GH1. This was P2, which is PA plus half rho P2 square plus rho GH2. So this part is 0, right? Then we can write this as P1 minus PA plus rho GH1 minus rho GH2, and that would be half rho V2 square, right? So this half rho V2 square, this is this thing P1 minus PA plus if I take rho G common, so H1 minus H2. What is H1 minus H2, guys? What is H1 minus H2?
Sir, same H1
Um,
minus H2.
Yeah.
H.
What did you say? H.
The H1 minus
No,
H2 is
Rishita
H.
is saying H. Ram- Yeah, yeah. So, yeah. Rishita is saying H. Akib, Amna, and Ram, what are your answers?
Same
What is your
H1
answer?
minus H2.
Yes, sir. Yes. H.
H. Right. So, good. So then this would be H. So half rho P2 square. This is P1 minus PA plus rho GH. And if I take this rho and to the other side, so V2 square would be 2. And this rho is divided, right? So P1 minus PA by rho plus rho GH by, right? So this row will cancel. And V2 would be how much? This would be root of this 2 bracket P1 minus PA by rho and plus GH. So this is the speed with which the water will come out of this hole. So this is called the effects, right? So this is called the speed of reflux, right? And what you do is that now let's say some cyclone or some high wind comes, and this top of the tank is water tank is gone, right? If this top is gone, then what will happen? So if the top of tank is on, right. So I should not write on, but open. Right. this thing is open, this thing is open now. So what can you guys tell me about P1? What would be P1? What would be P1, guys? This is open.
So that also atmospheric pressure.
Yeah, so that one would also be atmospheric pressure. Yes, absolutely correct. So this P1 would be P, right? Now let us look back at the speed of efflux. So then I should write P, right? Speed of efflux would be how much? This is how much of, and P minus PA divided by root and plus GH. So now if this is open, the top is open. So we can write P equals to P, right? So this V would be how much? This would be root PA minus PA divided by root plus GH. So this will cancel out and we will get what? This is root 2GH, right? So this is what is called the Tory series. So do you guys remember what is this root 2GH? Do you guys remember this thing? So if you have an object, right, which is falling from this h height, right? So what is the speed with which it is falling? So what would be the speed? Initial speed is 0, right? This height is h, and v square minus u square is 2gh. So this is 0, so v is 2gh. So this is a free fall, right? This is a free fall, right?
Yes, sir.
Fluids, if velocity, so then this fluid will fall like a free fall. So that is what this Torricelli's law states. So if we have the open surface, then the velocity with which those water will come up, that will behave like a free fall. So that is the Torricelli's. So is this thing clear, everyone?
Yes, sir.
Yes, sir.
Okay, then you guys please note it down, and yeah, this is the recap. So please, can you guys start? Please start revising, right? Do you have any question on this topic? Check that, you guys. Please note it down. In the meanwhile, I will check the question. Then with the question.
Done, sir.
Done, sir.
Done. Okay, yeah. What about the other people?
Yes, sir.
Then,
Yes, sir.
what did it? Yeah, then you guys please. Yeah, whenever you guys want me to scroll down, please tell.
Done, sir. Sir, done.
Done. Okay, then please move down this part. Yeah, whenever you guys have completed this thing, please tell.
Done, sir.
Done, everyone. Hmm. So, do you guys remember the third chapter, motion in a brain? Yes,
Little bit?
little bit. Yeah. What are you saying, Akib?
No. 70
Yeah,
80% remember.
72%,
70 to 80.
70 to 80. Okay, so what kind of motion is what kind of motion is it?
Sir, motion in straight line or motion in plane?
This motion, this liquid is falling from this tank in this way, right? So what kind of
Gravitational motion.
gravitational motion? What is gravitation?
A motion which is due to
Fall.
gravity.
Yeah, I'm
Yeah, free fall we
asking
can say.
that. Yeah, so I'm asking that in motion in a plane, what kind of motion was that? Yes, everyone, think about it and tell me. All of you guys think about it. So let's see. This object, this is following this path. So what kind of motion is this?
Sir, projectile.
Projectile, right? So this is some angular projection. But let's say the object is falling from this. So then this is the horizontal projection, right? So this is a projectile motion. So from this, we know that what is the speed? We know that that is root 2gh. So from this, we can calculate the other parameters, as well, right? So we have tank, right, and the water are being right. Right. So we can calculate this distance that they will travel. So what will this distance be called? What will be this distance called? Yeah, what is this distance? You guys have forgotten the projectile. What is this distance? Again, look at the example. So what is this distance? Sorry, is the eraser. Yeah, what is this distance?
Sir, you already told.
What happened? What happened to the system? What is happening? What is this? Can I? Yeah. So summary. If I press summary, I can get it in a. What was that? AI companion. What did I press? Take to text. Yeah. So what was this thing? This distance. What was this distance called? Oh, my voice converted into. Okay. So what was this thing in the projectile motion? What was this thing? This was
Range.
range, right? This was the horizontal range. So this is the range, right? The distance that it will cover horizontally, that will be the range. So you guys know that only there are no acceleration in the horizontal direction, right? And this height is h1, right? This height is h1, and there is no horizontal on there is no vertical motion. There is only the horizontal one, right? So we know that u uh, x is gh, right? Ax is 0. And then let's say we can also calculate the time, right? So we know that uy is 0, right? Ay is g, and this is s is h1. So we can calculate the final velocity as well as we can also calculate the time, right? Time it will take to flow from here to here. So time would be 1. We know that S is ut, which is uyt plus half ayt square. So S is h1, right? S is h1, uy is 0, so this is cancelled. This is half, ay is g, and t is t square. So the total time it will take this water to flow from here to here, that would be how much? 2h1 by g. Right, so this would be the t. Clear, guys?
Yes, sir.
So t would be this thing. So t, we know that that is t. And we have to find out r. Right, so we know that again, s would be how much? ux t plus half ax t square. So ax is 0, this is cancelled. S that is r that we want to calculate. Ux is root gh, and t is how much? That is root of 2h1g. So if we put this thing together, right? And this is so if we put these two things together, so this would be root gh1 by g. So this g will cancel, so we will get 2h1. So that would be the range. Is this thing clear, guys? So this
Yes,
would
sir.
be the distance the water will achieve, right? So this water will achieve this distance. Okay, so that is depending upon these two heights. So if we increase both the heights, right? If we increase the separation, if we increase this height, so this will go the farther distance, right? So that is the other quantity that we calculate. So please note down this thing, and if you guys have any question, please ask. This is the time to reach the bottom, right? And this is the distance forward in direction. Quickly note it down. We have to. Again, I wanted to start this. Yeah, you guys quickly note it down. And if you guys have any question, please tell me. Whenever you guys have noted it down, please tell me.
Done, sir.
Done, everyone. Okay, so now let us understand about some dynamic right. This part okay, everyone has noted. So now let us talk about dynamic, and what I will talk about is the arrow one, right? And what is this? So uplifting of an arrow plane, right? So you guys have traveled in the aeroplane. So what does this aeroplane do first? All the aeroplanes have what? When they fly. So firstly, what do they do? Yes. Can you directly just fly the aeroplane from that point? Let's say the aeroplane is here, right? The aeroplane is here. This is the aeroplane. And can you directly fly out this aeroplane from here? Yes. What do we do? We cannot
No, sir.
directly fly this aeroplane out, right? So we have this runway, right, on which this aeroplane runs, right? And when it achieves some velocity, when it achieves some velocity, then it flies in the air. So from there it flies, and that is what we are going to find out, and that uses this property of dynamic right? So you see that the wings of the aeroplane have specific structures, right? So they have some specific structures, and due to that, they have some different effects, right? So let's say that before we do that, let us remember that if velocity is high, then pressure would be what? If velocity is high, then pressure would be what? Low or high? If you increase the velocity, then pressure would increase or decrease. Yes? Don't understand. Okay. So it is running on the ground. This aeroplane is running on the ground, right? Is this thing clear?
Yes, sir.
Is this thing so this plane is on the ground. So if we apply the Bernoulli's principle to this aeroplane, right? So that would be how much, right? So winds are flowing at this aeroplane. So if we apply the Bernoulli's principle, so that would be V1 plus half rho V1 square, and that would be because mgh, let's say 1, and then P2 plus half rho V2 square plus mgh2. Now this is on the ground, so this part and this part is 0, right? And the plane is at rest, right? So plane is at rest, which means that V1 equals to V2, that is also 0. So this part also cancels. So we have a pressure, they are equal. So pressure which is applied on these wings, those are equal. Now the plane is moving, right? And it is on the ground again. So V1 plus half rho V1 square, that would be equal to V2 plus half rho V1 V2 square, right? So let me write this as this as P plus half rho V square. This would be constant. So if you increase the velocity, right? If you increase the velocity, so keep this thing constant, what should happen to this pressure? What should happen to this pressure? Yes, guys. Okay. So if let's say if 5 plus 8 is 30, clear? Now what you do is that you increase it to 10. So to keep it 30, that is constant, what should we do? This 5 should be how much? Hmm. Yes, guys. What should be 5?
So
We
3.
don't. Yes?
3.
Yes, what are you saying, Arish? What should be 5? The total is 30, right? So if this is 10, so this should be 3. Correct?
Sir, I told.
Oh, you already told, yeah. So I couldn't, yeah. Sorry about that. I
Even
couldn't
I
hear.
said,
Oh,
even I
even
said
you
3.
said also, yeah. So, okay. So if we increase this thing, right? So this will go down. So if we increase the velocity, if V1 is greater than V2, then pressure 1 would be smaller than pressure 2. Clear? Is this thing clear? This would be the idea that we will use. Idea in air. Is this thing clear, guys?
Yes, sir.
Okay, so now we make the structure of wings in such a way that they are of this kind of a shape, right? They are in this shape. So this part is thicker, this part is thin, right? So when the airs will strike this surface, so they will move like this, right? And the bottom one will be this. Okay, this is your air wings. Now, if you look at this thing, so they are covering a larger distance. So this, which one speed would be larger? Which one speed would be larger? Which one would be smaller? The bottom one or the upper one? Which one would be larger? Which one would be smaller? Yes. Which one would be larger? Which one would be smaller, guys? So they are covering larger distance. So they are covering equal distance. So this should be larger, right? So this V1 is larger. This V2 is smaller, right? So V1 is larger than V2. Clear? Is this thing
Yes, sir.
clear?
Yes, sir.
Firstly, what was happening is that there was no, so this plane was not moving, right? So then all these ones were with a different same speed. This was a stationary, right? So they were with the same speed. So the total pressure P1 and this P2 that was simple when these were stationary, right? Now it is this thing is moving, so this is clearing this air. So this will have a larger speed. This will have a smaller speed. So if V1 is larger than V2, then V1 would be smaller than V2, right? So this pressure is P1, right? And this pressure is P2. So P2 is greater than P1. So what will happen to this thing? Now velocity 1 is greater than velocity 2. So downward pressure is smaller than the upward pressure. So the wings will go up, right? Because they will move in this direction. Is this thing clear, guys? So that is how this aerofoil works. Because this
Yes,
pressure
sir.
is higher, so this will go upward, and the downward pressure is low. So the overall pressure P2 is upwards, so this will move upwards. And what would be the upward force? What would be the upward force? The upward force would be how much? That would be P2 minus P1 into area, right? Area of that. So F would be P2 minus, and you know that there is this, so there is this upward force, and the downward force is what? Gravity. So in the runway, on the runway, you achieve your upward force in a such a way that that overcomes the gravity. So you are increasing the speed in such a way that it becomes V1 becomes so large than V2, so that your gravity, so this upward pressure overcomes this gravity. Then this plane will lift upward. So that is the idea of this aerofoil. Is this thing clear, guys?
Yes, sir.
Is, okay, then you guys please note down this thing, and then we will do one numerical which is very important on this one. So I will, there are other uses as well. So we have this Magnus effect, right? So you guys please read that part. So that is you guys just write that part. So we have this ball, right? This is not swinging, and then this ball which is swinging. So it is making net angular momentum. It is creating a net angular momentum, and then it will uplift, right? So air pressure will be changed, and then this will change the path. So you guys please look into the Magnus effect from the book and read that and note it down, and that would be good. But before that, please write down this part.
Done, sir.
Yeah, then please down. Yeah, whenever you guys have wanted it down. This part is this and
Correct, sir.
Done, sir.
yeah, finished. Okay, so now let us one question which is very interesting, right? Yeah, one. Yeah, so what is the question? Yeah, so these parts you guys please, yeah, so these parts are your, right? Magnus effect, aerofoil we have done, right? So you guys please read this part. Right? This is a very lengthy process, and they have all the arguments, right? So, then this part I have covered, so you guys please. Okay, this is the question. So a fully loaded Boeing aircraft has a mass of 3.3 into 10 to the power 5 kg. Its total wing area is this. It is in level flight with a speed of, right. So it is in level flight. Estimate the pressure difference between the lower and upper surface of the wings, right. Estimate the fractional increase in the speed of the air on the upper surface of the wing relative to the lower surface. The density of air is this much, right? So first thing, what are the things which are given? So a fully loaded Boeing aircraft, so mass is given, right? Mass is given, which is 3.3 into 10 to the power 5. And its total area is, so area is also, this is 500 meters square, right? So it is in level flight with a speed of 960 kilometer per hour. So in level flight means that its average velocity is given, right? So V average is given, which is 960 kilometer per hour. And this would be in meter per second. How much would be this in meter per second? So kilometer is 1000, and then we have 36 centimeters. So that would be meter per second, right? So 0 is there, and yeah, how much is this? 12, and then we have 3, then we have 6, and then this is 5. This is 3, and this is 1. Right, so this is how much? 805 meter per second. Right. So this is the average velocity. Now we have to find out pressure difference between the lower and upper surface of the wings. So we have this area, right? And we can calculate the pressure. So force is how much? Force is mg, right? This thing we know. So this is a bar. And we have calculated the force. This was P2 minus P1 into A and mg. Right, guys? So this was, we have to find out the pressure difference. So pressure difference would be how much? That would be mg by A. So m is given 3.3 into 10 to the power 5. G is 10, and area is 500 meters square, right? So this would be how much? This part cancels out, and this we can, so let us take 3.3. Let us take 100 from here. So 100, and then this is 10 to the power 10, and this is 50. So this will be 2. So this is 6.6 into 10 to the power 3 Pascal, right? So this is the pressure difference. Is this thing clear, guys?
Yes, sir.
So this part was the pressure difference. Now estimate the fractional increase in the speed of air on the upper surface related to the lower surface. So fractional increase. Increase in velocity is how much? That is v2 minus v1. That is the increase in the velocity, right? And fractional increase would be the divided by this v average. So this is the thing that we have to calculate, right? And what is the law that relates v2 and v1? What is the law that relates v2 and v1? Yes, guys, what is the law that relates v2 and v1? Yeah, so already you guys have forgotten. Yes, Bernoulli's principle, right? B part, Bernoulli's from Bernoulli's principle, what do we know? B1 plus half rho B1 square. That would be B2 plus half rho B2 square. And we have cancelled out this MGH part because they are at same height, right? We know that this is flying, right? This plane is flying, but this is at the same height. So those have the same height, right? So if I write rho g h1, so this would be again rho g h1, rho g h1, rho g h1 can. So we will get this thing, right? So b1 plus half rho b1, right? And we have to find out the fractional change in v2, right? So if we take this thing in the other side, so let us take v1, right? Or let me write, let me take this thing in this thing. So half to v1 square minus half to p2 square. This would be p2 minus so if I take half rho common, this would be v1 square minus p2 square. And do we know the value of p2 minus p1? So this is given, right? This is 6.6 into 10 to the power 10. And this rho part is also given, right? And how much would be this v1 square minus v2 square? So this would be divided by, let us write this to be here. And this is divided by, so this thing v1 square minus v2 square, that is a square minus b square. So this I can write as v1 plus v2 and v1 minus v2, right? Divided by 2. This is 6.6 into 10 to the power 5. So what would be this v1 plus v2 by 2? What is this thing? What is this thing, guys? v1 plus v2 by 2. What is this thing? Yes, what is
V square, V1 square minus V2 square.
no, I'm asking about what is this thing? v1 plus v2 by 2. What is this?
Uh,
This is average velocity, right?
Yes, sir.
So this is v average and v1 minus v2 by 6.6 into 10 to the power 5. So if we divide this thing by v average, right? So if we take this part in the other side, right, and this would be how much? So 6.6 into 10 to the power 5 average, right? So we have to calculate V1 divided by V2, and it is divided by V average. So that would be how much? V1 by V2 divided by V average. So this would be 6.62 into 10 to the power 3. V average and V average, right? So this is this thing, because we want to calculate the fractional, estimate the fractional increase in the speed of air, right? So this is the thing that we want to calculate. Okay. So let us calculate this. So this would be how much? We know that V average is given, right? And this is the rho watts. So this is how much? V average was 800 by 16 whole square into rho. Rho was how much? Rho was 1.2 kg per meter, right? So this was 1.2 kg per meter. So all these are in SI units. So we can write this thing as how much? And 800 into 800. This 3 will go in the upstairs, and this is 1.2. So this is how much? 6.6 into 9 into 10 to the power 6 minus 10 to the power minus divided by 8 into 1.2. So how much is this? 9.2. And this is 9.6 into 10 to the power minus. So how much is this thing? If we calculate this thing, so 59.4 divided by 9. It is 6.185, right? Did I do some? I'm getting this 6.1875 into 10 to the power minus, which is 0.61. Right. This is the fractional change that I'm getting. But in here, what they are getting? They are getting 0.08. Now, so 6.5 into 10 to the power 3. That thing is correct. 6.6 into 10 to the power 3. And this is 267. Okay. So how much we are getting? So if we have 960 into, this is 1536. This is 5, this is 80. So 960 into 5 divided by 80. So this is 266, yeah, so 800 by 3. Yeah, so this is correct. So what is the wrong thing that we have done? Oh, so P2 minus P1 is 6.6. Yeah, so that we have taken 6.6 into 10 to the power 3. And we have also got rho into P average square. So that we have also done 1.2 kg per meter cube. Yeah, that's what is the problem here. Calculation. So 6.6 into 10 to the power 3 divided by 800 square. So this is what we get, right? So 9 and what is wrong here? Can you guys find out? Because this is the exact thing that we have calculated, right? Delta P by rho behaved square. So delta P we have got 6.6 and this one we have, yeah, so this is also 267. How will we get 6.63 into 10 to the power and 800 by 800, and 10 to the power 3 and oh yeah, yeah. So I have found this one. So there is 1 8 so this is divided by 8, so this is divided by 8. So how much is the 0.61 divided by 0.077? 0.077. So that is the answer that we get. Okay, you guys please note this thing down. And yeah, then we'll next class
Sir,
we'll complete the next. So please, you guys, do you guys have any question from this? Yes, yes, your voice broke in the middle. Yeah, what are you saying? I cannot hear. Yes, anybody can? Yes.
nothing, sir. I just said that I wrote already.
Oh, you have wrote all the things. Okay, yeah. Then, other people can put it down, and yeah, then we'll stop. So you guys, please stop. You note it down and then stop in next class we'll finish this chapters. As Akif said that this is a very long chapter. In the next part we'll talk about the thermal properties of the matter, but after
Done, sir.
yes, done. Okay, then please This is the fractional change. Right? This question is very important. What are disconnected?
Done, sir.
The alarm is. Yes, you guys, please.